Dr. J. Kamala received her BE in Electronics and Communication Engineering from Madurai Kamaraj University in 1989, ME in VLSI Design from Bharatdasan University in 2002, and PhD from Anna University in 2011. She is currently working as Associate Professor in the Department of Electronics and Communication Engineering, Anna University, Chennai. Her research interest includes VLSI design, solar power, controller design, and smart sensors. She has published several papers at national and international journals.
Welcome to the UGC lecture series on agricultural engineering. Today we are going to see about renewable energy part 7. In this part we are going to see about solar pumping system. Solar pumping system is a clean, simple and energy efficient alternative to traditional electric and fuel run pump sets. The conventional and old systems are electrically driven or fuel driven. This solar pumping system consists of mainly three components. They are solar panel, a controller and motor. The controller receives energy from the solar panel. According to the motor, it will provide the necessary control signals to run the motor. So, the PV module, it may be of polysilicon or monosilicon crystalline solar panels of higher capacity to drive the motor. Controller, it will take care of the running of motor with all safety measures. Then electric motor with pump, it is used for pumping the water for agriculture applications. So, these are the four major components of solar pumping system. The design specifications, how do we choose the components for a solar pumping system? First one is available solar energy. How much output we get from the solar panel. According to the environment and the location, we get higher output from the solar panel. What is the maximum or optimum power output from the solar panel? That depends on the available solar energy. The solar radiation from the sun is called solar insolation. This solar insolation decides the power output of solar panel. If we have higher radiation for a longer period, we will get more output from the solar panel for a long time. Next one is volume of water to be required or pumped in a period of time. Whether it is and the purpose, is it for livestock or irrigation purpose or storage. If we need storage, mostly storage volume, the amount of water we used to storage is usually 3-day water requirement for backup. Even in cloudy days or some other safety applications, we can store the water. In cloudy days, we don't get solar output. In that time, we can use the stored water. Then total dynamic head of the pump. The total dynamic head is the equivalent amount of water to be pumped out. This is to be decided. Accordingly, we have to choose the pump. Then quantity and quality of available water. How much water is available, and water is available whether below the surface of the earth or it is at the level of the surface, and at what depth the water is available, how much water is available, whether the water is salty or it is polluted by some other chemicals or is it in pure form. All these things are to be noted to choose the proper solar pump. Then system proposed layout and hydraulic criteria. These are to these are the design specifications of a solar pumping system. First we will see solar panel. The solar power supply for the pump specify the panel output, and the solar panel performance degrades after the installation. During the first year the solar output will be very high, and the second year the solar output is reduced little bit. Third year the output is again reduced. Like this, for a 10-year period of lifetime, we have to allow the degradable performance of solar panel. So, a 10% degradation is to be allowed. That means, if the solar pump requires 10 kilowatt means above 10 kilowatt a 10% is to be added, so that the degradation of the solar panel will not affect after the subsequent years of installation of solar panel. So, in excess of 10% of the pump output or pump specification, we have to choose the solar panel. And the solar panel characteristics, if we see, this is the x axis we are plotting the voltage output from the solar panel, y axis we are plotting the current output of the solar panel. If the voltage increases, current will be decreasing. That is when there is no load. Okay, no load means nothing is connected across the solar panel. It is similar to open circuit, that is denoted by VOC. VOC is open circuit voltage of the solar panel, and it will be very high. When VOC is very high, the current will be 0. That is, the VOC is placed in the x axis at a highest voltage. Similarly, another important parameter is short circuit current. If we short the solar panel terminals, no load is connected, just we are connecting a short, that time the voltage will be 0 and current will be very high. So, that ISC, short circuit current, will be in the y axis and voltage at that point is 0. So, if we increase the voltage from 0 means the current is stable for particular point, and when it reaches VOC, the current is gradually 0. The power output from the solar panel is multiplication of voltage and current. If we multiply it, we will get this blue color curve. The maximum power we will get at this point. So, this is the point we want to operate the solar panel. This point is called maximum power point. PMP is maximum power point. If you operate the solar panel at this voltage and at this current, we get maximum power from this panel. So, we have to design circuits such that we operate the solar panel at this point. This is the maximum power point. The voltage corresponding to PMP is the VMP, and the current corresponding to PMP is IMP. So, these parameters are important: VOC, ISC, PMP, VMP and IMP. Mostly we see the PMP, VMP, IMP, that is maximum power point, power, voltage, current. Maximum power point parameters of solar panel for the particular application. And for solar pumping applications, we always use high power solar panels according to the motor or pump we are using for the solar pumping system. Next one is solar panel installation. Solar panel can be installed such that it can track the sun. When the solar panel is pointed towards the sun, we will get more power. But tracking the sun is very complicated, and we need more power and circuit, and higher cost is involved. So we normally choose optimum point or position for installation. So solar panel is always installed stationary, it is not moving, and it is oriented towards south to take advantage of the maximum sunlight available, and the sunlight available will be in the middle of the day. And tilting angle, it is not placed horizontally, the PV panel is placed at an angle with a tilting angle, and it is equal to the latitude of the location. At the tilting angle we get maximum sunlight from the sun, and the tilt angle will be varying in the summer as well as in the winter, because the sun position will be varying in different periods. In the summer period, the tilt angle is made latitude minus 15 degree. During that time the sun is higher in the sky, and during winter time the tilt angle is placed at latitude plus 15 degree. During winter period the sun is lower in the sky, so we choose the tilt angle as latitude plus 15 degree. The tilt angle are to be adjusted at the spring and autumn equinoxes. They are respectively March 21st and September 21st of each year. So the solar panel is to be installed at a proper place without shade, because if any shade is there it will affect the solar panel output. To avoid it, we have to choose the location without any shadows. And if we use solar panel exactly above the surface of the earth in the field, that area cannot be used for cultivation, because the solar panel shade will be available in the field and it cannot be used. So if we place the solar panels above the ground level at a particular height, we get dynamic shading. That means we will get sun energy for some period. We can use that field for cultivation. That is the solar panel installation procedure. Next, electrical controller. From the solar panel we get the input and it is converted into proper form so that the pump delivers the water, and the controller also provides electrical protection and switching. If we see the controller, it will be it has to control main switch and float switch and the voltage regulator application also. The controller is connected to the solar panel through a main switch. So if sun energy is not there, or if it is not used, means the solar panel is disconnected from other systems using by opening the main switch. Similarly, controller switch on the pump set or motor using pressure switch or float switch. If we use pressure switch, means there will be a pressure tank. If we use float switch, means it will be a storage tank. That depends on the circuit we are using. So the controller converts the electrical power from the solar panel into the required output voltage of the pump set. Then it will so that we get the output, and it will also provides protection also against rain, lightning and other things. Another function of controller is maximum power point tracking. Already we have seen in the solar panel VI characteristics, the maximum power we will get only at VMP and IMP. So to operate the solar panel at maximum power point, the controller is implemented with an algorithm using microprocessor or microcontroller, so that we get maximum power from the solar panel. So it also function for maximum power point tracker. So main switch is used to disconnect the PV and other systems when not in use and in emergency situations. Switches, other switches are used to prevent the motor or protect the motor from low water dry run protection and other applications. We can use float or pressure switch for the pump. So these are the functions of electrical controllers, and we have to use proper grounding to prevent damage due to rain and lightning. The controller is an electronic circuit. It is enclosed in a proper box or a waterproof design, so that rainwater will not enter the controller circuit and damage it. So we have to waterproof the controller circuit to protect it from the rain. Next one is solar pump selection. We have to consider TDH, total dynamic head in feet. Accordingly, we have to select the pump. Then water source, whether the water source is in surface or it is in the well. Next one is available electrical power. What is the peak power we will get from the sun, and the how much energy provided by the solar panel. If it is not available, we have to get from the grid. Then water requirement, how much water you want to pump out in a day, that is flow rate or volume in a given period, and whether it includes storage or not. So solar pumps, if we see, we are having different types of solar pumps. The first one is submersible solar pumps. This one is used to lift the water up to 650 feet, and it can be fit inside the big well. For example, this blue color is a well, and inside the water we are having the pump. The pump is represented in red color, and we will be using water level sensors because the submersible pump is always submerged in the water. So sensors are required to indicate it. Water deepness in the well is about 20 feet from the surface, means we use this type of solar pumps, and it is used in areas where water is accessible only at a larger depth and open wells do not exist there. That time we use submersible solar pumps, and highest suggested depth for this pump is around 50 meters. Next type of solar pumps are surface solar pumps. It is used to pump water from ponds, shallow wells, storage tanks, otherwise streams. The pump is placed above the surface, and water is also nearer to this. The deepness of the water supply in the well is 20 feet or less than 20 feet. If it is greater than 20 feet, we will go for submersible pump. Here it is less than 20 feet, and it can push water 200 feet or above from the surface of the water. This is surface solar pumps, and it is suitable for lifting the water from the highest deepness of 20 meters. Next one is DC pumps. These are the pumps work with direct current. If the pump works with direct current, the controller does not include inverter. The function of inverter is converting the DC into AC. Since this pump works at DC, we don't use inverter in the controller. Here some of the specifications of solar shallow well pumping system is given. For example, a PV array of 900 watt peak, they are using centrifugal DC monoblock, 1 horsepower motor, 60 volt DC operating voltage, and section head is 7 meters, TDH is 10 meters. The area required for installation is 30 square meters. It can pump about 77,000 liters per day from a TDH of 10 meters. If we increase the solar panel capacity to 1800 watt peak, we can use a 2 horsepower motor and pump set is centrifugal DC monoblock 60 volt, and here the TDH is greater, that is around 15 meters. Area required for the installation is also increased about 75 square meter, and water is also increased, 154,000 liters per day can be delivered from a head of 10 meters. Again, if we increase the solar panel capacity to 2700 watt peak, we can use a 3 horsepower motor with a 90 volt DC operating voltage with a 25 meter TDH, and we can pump about 115,000 liters per day from total head of 20 meters. So, these are the few specifications of DC motors. Next one is AC pumps. It works with AC. So, we need inverter. The function of inverter is to convert DC voltage into AC voltage. So, the controller includes inverter. Here these pumps are used for solar deep well. Here if we see the 1200 watt peak PV array is used with a submersible motor and TDH of 50 meters and 34,000 liters it can pump. If you use 1800 watt peak, it can pump about 51,000 liters of water. With 3000 watt peak of solar panel, it can pump around 51,000 liters per day from a total head of 50 meters. With 4800 watt peak of solar panel with a submersible pump, it can have a TDH of 80 meters and it can pump about 82,000 liters per day from the total head of 50 meters. So, as the solar panel capacity is increased, we can use a higher capacity motor to pump more water from the well or surface with a maximum TDH. These are the AC examples for AC pumps. Next one is electric motors. We can have different types of electric motors. First one is AC induction motor. It can be directly driven from grid, less maintenance, used in water pumps, kitchen application, fire, air condition, everything, and it is maintenance free. Once it is installed means we need not worry about the motor. That is the AC induction motor. Next one is stepper motor. Stepper motor is used where your application requires lot of repeatability, accurate positioning, fast response for start, stop, reverse, speed control and stability are required. Mostly these stepper motors are used in robotic applications, not for pumping application. Mostly for robotic applications where these features are required. Next one is permanent magnet DC brushed motor. They are simply called DC motors. They are reliable, efficient and inexpensive. Due to brush wear, it is having limited lifetime and it is used in most of the applications. These motors are driven by DC signal, so it is suitable for all solar powered applications, and this motor is available in various ranges from 12 volt and 0.5 amps to very high amps, and different types of applications. All electrical appliances use this type of DC motors. And next one is brushless DC motor. It is a new type of motor and it is very small but expensive. Compared to other motors, it is having better torque and speed characteristics. The lifetime is increased, low power dissipation, but the control circuit is complex. That is the major problem, and it is expensive also, and the cabling requirements are very simple in case of brushless DC motor. Next we see about solar pump sets. Solar pump sets, if we see, we are having different types. Surface mounted DC motor pump set. The DC motor is placed on the surface above the water level, and it is used in the to water from streams, lake, pond, like that. Next one is submersible DC motor pump set. They are all used when water is at so deep and the motor is placed inside the water. That is the submersible DC motor pump set. Next one is submersible AC motor. Some motors operate in DC signal, some motors operate in AC. So all the motors we can have both AC and DC. Submersible AC motor means same type of motor operated with the AC. And floating DC motor pump set. It is semi submersible. The motor is placed above the water level in a floating surface such that it can be adjusted. Even the floating DC motor can be made as a submersible DC motor by adding some components. The motors, we can have monoblock motors. Monoblock motors means the motor and pump are coupled in the same unit, and because of this the coupling losses and transmission losses are reduced. We have seen already in the DC motor applications, the centrifugal DC monoblock motor is used. Here monoblock refers to the motor and pump are coupled in the same cabin. That is the monoblock motors. Most of the motors we are having in solar pump sets are monoblock, and there we are having different types: centrifugal monoblock motor, agricultural monoblock motor, booster monoblock motor, and surface submersible motors. In this, booster monoblock motors are used to pump water with gas. Other motors are used for watering application only. So the solar pumping system, if we see, it is environmental friendly because it does not require any electricity or fuel. It derives the energy from the sun using solar panel, so it is environmental friendly. And longer lifespan, both solar panel and the motors associated with the panels are given with longer life warranty, so it is having longer lifespan. But the disadvantages, the advantages, if you see, they are environmental friendly, longer lifespan. The disadvantages, if you see, the initial installation cost is very high, and weather dependent. If our season is not sunny and it is always cloudy or rainy, means the solar panels cannot be operated. But for a water pumping system, during a rainy days water is not required, so it is not a major drawback. Weather dependent, only if it is sunny. For agriculture purpose, it is not a major drawback. If it is rainy, means it is not necessary to water the field. And shadow free area, we need a larger area to install the solar panel without any shadows, and the area under the solar panel cannot be used if the panel is installed near the earth, because the earth is always under the shade of the solar panel. We can't cultivate it. If we install it at a particular height, it can be used for cultivation, then it is called agrophotovoltaic system or agrovoltaic system. So, these are the advantages, and we have seen the solar pumping system. Thank you.